Hey everyone, it's Tyler from CG Forge. In this video, I'll cover everything you ought to know about the point velocity node. I'll show you how it works, and then we'll go over each parameter in fine detail. The main reason why you might want to use the point velocity node is to generate a velocity attribute that describes which direction an object is moving. Now, once you have this information, you can then take it to a simulation, or you can use other sorts of techniques along with velocity to create interesting effects. But for now, let's say that we have this axe and we have the point velocity. By default, what this does is it starts by figuring out the velocity based on the object's motion. So if I move this forward in time, we can see with our velocity preview on right here that these blue lines describe which way the axe is moving. We can also see this information numerically by holding down the middle mouse over the node and seeing that we have velocity, which is right here as a point attribute. And if we go to the Geo spreadsheets, this also has velocity described right here. These numbers describe how far it's going to move in 1 second. So it describes the direction in XYZ relative to its current position, as well as how far it's going to go in 1 second. That's what these numbers are saying. So if you think of it like an offset from its position, that's what velocity is. Now, the other thing that this does is it calculates additional noise patterns, or it breaks up these values in interesting ways. So right here, we start by creating a base value for velocity. And then on top of that, we can break it up with a curl noise. So if I turn this on and I scale this up, we can see that these vectors are now pointing in different directions based on a noise pattern. I can change the swirl size here to make these shapes smaller or larger. And these all relate to controlling the shape that you like for breaking up these vectors. We also have this conical noise. And the way to think about this is it's going to take every single velocity vector and it's going to rotate it randomly within some sort of degrees. So if I turn up the cone angle here, this is the maximum angle at which it's able to push these vectors towards. So at a value of 180, that's going to be essentially perpendicular to the velocity direction. And then as I turn this up, we could see everything fan out in random directions. So when this cone angle is smaller, we can see that nothing changes at 0, but then this opens up as I turn the cone angle up, and it makes this cone shape, which, makes sense for the cone angle. And these are the two main things that are going to change the shape or the direction of your velocity vectors. In addition to that, we have this option that says from object. What that is saying is instead of getting your animation here within SOPs, you can alternatively get the animation here from the object level. Hence, that's why it's called object or from object right here, and add object motion right there. When it says object, it's talking about the object level here, the OBJ level. And so this tab is here to pick up information from that level and then calculate the velocity vectors based on that. That's a basic overview of what's here in this tab, but let's go over some more details and I'll show you how you can use this in an interesting way. As I mentioned before, this first tab is going to establish the base velocity that then will change as we go along. So at first, compute from deformation is going to look at the object as it's moving around in SOPs here. Again, if you have animation here on the object level, that's not going to work. Instead, you'll need to use this from object tab, and then it's going to pick up information that's on the object level. But assuming that things are moving in SOPs, this will pick that up. The frame sample here is going to describe how far back this is going to look. So the animation here starts at frame 24, and notice what happens when I turn up this frame sample. What's going to happen is that it'll look further and further back in time So if I'm on frame 29, it's going to look before frame 29 further and further up until, let's say, 10 frames. And the resulting velocity that it gets is going to be a blend between what happened 10 frames ago and what happened 1 frame ago. So if this is down here at a value of 1, it'll look at frame 28 and base the velocity value on that. If I turn this up, it's going to blend the velocities going 10 frames back. And so the higher you turn this up, the more generalized your velocity motion is going to be based on where the axe was. So we could see that as it's moving, it's taking information from 10 frames ago and it's averaging all of those things out. Usually I would suggest turning this to the defaults of 1. You probably want to look 1 frame back in time and not 10. But in the future, you might have situations where the movement is very jittery. That means that the point is just moving in random directions really fast. And if that's ever happening, then you might want to average things out to smoothen the resulting velocity. And so this is basically like a smoothening of the motion. Before we continue on with these other parameters, let's quickly talk about the top sections here. This group field is going to allow you to specify a group of points to work on. So if I want to do this only for the points at the head of the axe, as an example, I can make a group for that. Let's say that we have this group, and then I will select the points on the top of the axe. We'll call this our axe group. Now that I have this group, I'm going to copy the name and we'll paste it here in the point velocity. And now this will only work on those points and ignore everything else. The add velocity will simply just add to the values. So this might be useful if, let's say, you're creating points for fire or something that moves up in the Y direction. So let's say that I did want fire at the top of this axe head and I wanted to describe that initial motion. I might say start with a value of 5 going positive in the Y direction. And now it's going to take the movement of the axe plus it's going to try to add 5 to whatever that value is, and that's going to be the resulting velocity. So this just adds. The next one here is calculate speed. This describes how fast the object is moving. So if we take a look at our geo spreadsheets, this speed right here is going to essentially describe how long the vectors are. It's one value, it's how many meters long these blue lines are. And the longer the blue line is, the faster the movement is, because the velocity is going to be offsetting the points further and further over 1 second. So that's a way of thinking about it. This describes how long is that velocity vector if you were to measure it, and then based on that, you can do whatever you'd like. Speed gets used for all kinds of different things, and just off the top of my head, if let's say you wanted to only spawn points where things are moving fast, having this speed attribute can allow you to isolate the points that are moving fast versus the ones that are not. And, well, you can get creative in how you want to use that, but there it is. Moving on now, we have this evaluate within frame range. And what this is going to do is allow us to decide when we want this behavior to happen. So when we calculate that initial velocity, you can have that only occur between certain frames if you'd like. So that's the option for controlling that. Velocity approximation. This determines how velocity is calculated. By default, the backwards difference is going to take the difference between the current position and the previous position, hence difference, or hence backwards difference. It's looking back and it's finding the difference. But you can change this. So you can say central difference as an example. Now, every single point along the mesh is going to look forward in the future and it's going to look backwards. So we're finding the center value between what's about to happen and what happened previously. And based on that, it's going to change the velocity vector that you get. And then lastly, we have the forward difference, which looks at the point ahead of its current position and then angles the velocity vector based on that. It's not very obvious just by looking at this, but we do get slightly different angles here when we change this mode. So just keep that in mind as you're going. Typically, I do central difference or I do backwards difference. You'll need to have central difference if you were to use this acceleration attribute, which I'll talk about here in a moment. So do keep that in mind. The acceleration only works when doing central difference, but if you're just looking for velocity, backwards is just fine. Speaking of the devil, we have compute acceleration. This attribute most commonly gets used when you're trying to create better looking motion blur. So if you want motion blur that's curved as it moves along an arc, acceleration is going to give you the ingredients necessary for a render engine to calculate that. Now, there are other ways that you can use acceleration, but think of this as the way in which velocity is changing over time. So if we are accelerating, we are getting faster and faster. And this describes how velocity is changing over time. So I'm at frame 16 right now. The axe hasn't moved. It moves at frame 24. And here the acceleration is 0. As the axe begins to move, so too does our acceleration increase in value. And then as we get to the fast parts of the axe moving up in the y direction and swinging over, we can see acceleration also increases its magnitude. Then at the end of this animation, the values go to 0 because we are at a standstill, because velocity is no longer changing its magnitude. So that's what acceleration is describing. Again, the main reason why you might want this is to calculate motion blur. There are other reasons why you might want acceleration, but for now, just know that that's typically why you might want that info. The next option here is angular velocity. And a good way of thinking about this is this attribute is going to describe any kind of spin that a point might have. Here we're looking at a mesh, so these points are part of polygons. They're part of a primitive setup. But if we were to just remove everything but the points, I have this add node and I said delete everything but the points, we can see that we're looking at essentially particles that are along this mesh, and W, that is angular velocity, will describe how those particles spin over time. So when we go to our GeoSpreadsheet, we see that angular velocity is represented by W, and by default, this is not going to show you any values based on our mesh right now. So if we go here to the particle origins option, this will show us the orientation of our particles. And W is essentially going to measure the change in this orientation. If something spins, its orientation changes. And, well, if we want W to show something, we need to change these orientations in some kind of way. So as an example of that, I'm going to set down a normal node right here and a scatter align. For more information about orientations and the scatter align node, check out the scatter align node Bible entry. And for orientations, check out my course Houdini Principles and then watch through the orientations chapter on that. But essentially by doing this, we now have an orientation set for these particles, and these orientations are going to change over time. So now, when this point velocity goes to calculate angular velocity, W is going to have a different value. So if we isolate W, we can see that this describes the way that the orientation changes over time. Now, in practice, why would you want this? Well, you might want this because angular velocity is going to give you a different result when you go to simulate something. Imagine that you had a piece of cloth as an example and you're simulating with vellum. Well, if there's some kind of angular velocity, if there's some kind of twisting of the points, you might be able to get some sort of interesting movements with, let's say, the end of the cloth kicking up or something like that. Anything that has angular velocity can essentially cause the mesh to spin in a certain way. And that could be very useful if you're trying to achieve a certain look during a simulation. That's just one example of what W might be useful for. But there it is right there. If you'd like to, again, capture the change in orientation to give you W, then you just check that on and it will give you that info. Last but not least, we have match by attributes. This is going to change the way in which the node identifies points in the future and in the past. So when we said compute from deformation and central difference here, we said, hey, look to the future and look to the past in order to figure out velocity. Now, when it does that, it's going to look at the point IDs and match those up by default. But if for any reason the point IDs change, it won't be looking at the right spot when it goes to calculate velocity. So instead, if you'd like to override that behavior by using an attribute value to match up where it looks, that's what ID can do right here. And for more information on this, also check out Houdini for the New Artist 2, where I talk about this ID attribute and show you an example of how it's used. So that is the main parameters here when we're talking about the compute from deformation. We have keep incoming. That means don't change any incoming velocity. We can also set this to a specific value. This will get added to whatever you set up here. And we also have from attributes. So if you want to use, let's say, the normal values as a starting place for velocity, that's what this can do. It just takes the attribute and then copies it over to velocity to get you some values to start with. Let's now take a look at something more fun and practical with what you can do with the point velocity node. Here I have a particle simulation. It's isolated just to the blade of the axe. And after a little while here, particles begin to spawn, and the initial movement of those particles is determined by this point velocity. So the velocity goes into the pop solver. The pop solver recognizes that, and then when it spawns particles, the movement follows that direction. So as we change things with, let's say, the curl noise, we can then break up this pattern in interesting ways. So going back here to the point velocity, let's take a look at our vectors here. We can see that they are changing over time, like this. Let's set this back to the defaults here for a moment. And what I'll do to start things off is I will just keep the defaults like so, and maybe just add a little bit of extra scale in there. That just adds more of this curl noise effect. When it says scale, you're just literally scaling the value that gets added to velocity. So this curl noise comes up with the value that then gets added to velocity, and that's what breaks things up. So even with just a tiny bit of curl noise, that's going to make a big difference to the motion of our particles. It's going to break things up a lot. So we can kind of see that it's not just following a boring old shape going straight up in the Y direction. It has a little bit more life to it now. But another thing that we can do to make this more interesting is add another point velocity node. This is something that I often do when I'm trying to make interesting sources for simulations. I'll then just say, keep the incoming velocity. I just want to create a curl noise and add that on top of what's happening. But maybe this time for the swirl size, I'll take about a third of that size. So now I have a curl noise that's a large shape up here, and then I have a smaller shape with another point velocity node down here. And so by layering up these point velocity nodes, you can really start getting some interesting sourcing from everything. So here we have a combination of large breakup and smaller breakup. And by doing this a few times, you can take a source for a simulation and vastly improve the overall shape of everything that's happening. So that's why this node is very important. That's why I use it all the time. By breaking up velocity vectors, you're going to break up your simulation because it's heading in different directions. As mentioned before, you also have a conical noise. So if you want to just have a bit of general randomization for each individual point along the mesh, you can do this as well. And that breaks things up even more. But do be careful with the conical noise because at a certain point, everything just looks really fuzzy. And you actually will blur out any detail in the motion if you add too much of this conical noise. So as an example, if I just turn this up to 5, it would just create a big kind of poof ball at a certain point, and then I don't really have any detail because it's just going in all directions. It doesn't have any shape to it. So there you have it. With the curl noise parameters here, I'm not going to really cover these parameters because they follow the same parameters that you would expect from any noise. And if you're not sure on how to understand that, definitely check out the Shading Techniques 3 course that I have, where I go more into what grain and turbulence and lacunarity and all these different terms talk about when you have a noise. But it's essentially a shape that gets generated, and this breaks up the motion. Last but not least, if you have animation here at the object level, like this, as an example, and you want the point velocity to pick up on that, say from object, go ahead and select the network that we have. So this is our AXGeo network. And then by doing that, we're able to, let's just say, keep incoming. So we start with no velocity that's being read in. And now this tab is taking over. And now we have our velocity happening right there. And just so that we can see this, let's turn off the curl noise and this as well. And we can see that is just the velocity vectors right here. If I scale this up, we can see this a little bit easier. So there we go. There you have it. That's everything you ought to know about the point velocity node. For more Node Bible entries, check out cgforge.com. Thanks for watching and have a great day.